In this video, we will explore the importance and essential steps of calibrating the sensors of a UAV. Why is calibration necessary? UAV sensors such as the gyroscope, accelerometer, magnetometer, and barometer ensure the stability and precision of the flight. Without proper calibration, the data provided may be inaccurate, which can affect the control and performance of the drone. We will analyze how to identify the need for calibration, what tools are necessary, and how to perform the process step by step to keep the sensors within optimal parameters. Required tools and software. Physical tools. Flat, stable surfaces for calibrating the accelerometer. A portable compass for calibrating the magnetometer. A spirit level to check the UAV's position. Calibration software. Betaflight NF configurator for FPV drones. Mission Planner Q. Ground controller for UAVs with autopilot. DJI Assistant 2 for DJI drones. PX4 firmware tools for professional UAVs. Calibration of each type of sensor. Calibration of the IMU sensor, which includes both the accelerometer and gyroscope. When should the IMU sensor be calibrated? After any impact or crash. After replacing electronic components. If the UAV tilts or vibrates abnormally. Calibration procedure. Place the UAV on a perfectly flat and stable surface. Connect the UAV to the calibration software. Go to the IMU calibration section and start the calibration process. The software will ask us to position the UAV in multiple orientations. Up, down, sideways, front, and back. Hold the UAV in each position for 5 to 10 seconds. After completion, check in the software if the accelerometer values are close to 0, 0, 0, and the gyroscope shows 0 degrees per second at rest. Save the settings and restart the UAV. Magnetometer calibration. When should the magnetometer be calibrated? After moving the UAV to a new location. After mounting new metal components, such as batteries, motors, antennas. If the UAV shows heading errors. Calibration procedure. Move the UAV away from any sources of electromagnetic interference, such as high voltage cables, mobile phones, and electronic equipment. Connect the UAV to the configuration software and go to the magnetometer calibration option. Rotate the UV in all directions. 360 degrees around the x-axis, i.e. left-right. 360 degrees around the y-axis, i.e. up-down. 360 degrees around the z-axis, i.e. front-back. The software will record the data and automatically analyze the calibration. Check in the software if the north is correctly indicated. If the compass still has errors, perform manual compensation. Adjusting the electromagnetic interference settings. Barometer calibration. When should the barometer be calibrated? After significant changes in temperature or altitude. If the UAV has abnormal altitude variations. Calibration procedure. Ensure that the UAV is in an environment without strong air currents, away from wind or air conditioning. Connect the UAV to the configuration software. Go to the barometer calibration section. The UAV will stay still for a few seconds and measure the atmospheric pressure. After calibration, check if the displayed altitude is metereal when the UAV is on the ground. Test the barometer by manually raising the UAV and observing if the altitude reading changes correctly. GPS module calibration. The GPS module should be calibrated when the UAV has been moved a greater distance from the last flight location. If the UAV has issues maintaining GPS position, calibration procedure. Go to an open area, far from buildings and trees. Turn on the UAV and wait for it to lock on to at least 8 satellites. The process may take 5 to 15 minutes. Check the UAV's position on the map in the software. If the position is unstable, perform a recalibration of the compass as the magnetometer affects the GPS. Calibration of optical and obstacle avoidance sensors. Optical sensors should be calibrated when the UAV does not respond correctly to obstacles after impact or lens cleaning. Calibration procedure. Clean the sensors with a soft cloth to remove dust or dirt. Place the UAV on the ground in a well-lit environment. Access the UAV software and start the optical sensor calibration. Test the sensor's response. Bring an object close to the UAV at different distances and observe if the UAV detects obstacles in real time. Conclusions and recommendations. Calibrate the sensors regularly for accurate and safe flights. Perform calibration in an environment free of electromagnetic interference. Check the live data in the software to confirm the calibration's success. After calibration, perform a low-altitude flight test to validate the sensors.